Okay, the next few exercises of Hall and Knight Higher Algebra chapter 6b would be about how to find the number of balls that have been arranged in a pyramid. So let us consider a simpler case first. We have a square pyramid like this over here. You can see that this is a square pyramid with the bottom most layer consisting of 4 balls. So 1, 2, 3, 4, right? So this is the bottommost layer, and on top of that layer we will have a square base of 3 balls, and then on top of this 3 balls we will have a square base of 2 balls on each side, and on the top layer you will have 1 ball. So what is the total number of balls here? It is 1 plus 4 plus 9 plus 16, and we can see that where is this going? This is simply sum of the squares of natural numbers, for which we already know how to find the sum. So if the square has a base of n balls, then the total number of balls S is simply n square, which is the bottommost layer, plus n minus 1 square, which is the second most layer, then so on up to the top layer, which will have only 1 ball, which is 1 square, and this is given by n times n plus 1 times 2n plus 1 divided by 6, right? Now let us consider the second case of equilateral triangle. Suppose we have a equilateral triangle of base 6, right? The bottommost layer has, each side has 6 balls. So 1, 2, 3, 4, 5, 6. Now if this base has 6 balls on each side, what is the number of balls on the bottommost layer? Now you can see that it is 1, it is 1, let us use a different color for this one. Yeah, so we can see that this is 1 ball, this is 2 balls, this is 3, 4, 5 and 6, and if we add all these numbers up, 1, 2, 3, 4, 5, 6, we get 21. So if the equilateral triangle, the bottommost layer has n balls on each side, then the total balls in that layer, okay, we are only talking about the bottommost layer, in that layer is simply the sum of those natural numbers, which is sigma n, right, which is n times n plus 1 divided by 2, right? Now note that this is the number of balls in the bottommost layer. What happens on the second most bottom layer? We will have a equilateral triangle with 5 balls on each side, and that will be simply sigma n minus 1, which will be n minus 1 times n divided by 2, and so on. We'll do all this to the top layer, which is only sigma 1. So you will have sigma 1, which is 1 times 2 divided by 2, right? Now if we have to find the total number of balls in this complete pyramid that we have formed with this triangle, we have to add all these numbers, right? We have to add 1 plus 3 plus 6 plus 10 plus 15 plus 21. That is, we have to add this all the way up to this, right? Which is nothing but, we can say that this is simply half times sigma n times n plus 1, and we already know how to solve this. This is actually equal to sigma of n square plus sigma of n, right? And sigma of n square, so we can write S is equal to half times sigma of n square is given by n times n plus 1 times 2n plus 1 divided by 6, and sigma of n is given by n times n plus 1, and we can take n times n plus 1 divided by 6. So sorry, this is divided by 2. So now we can take out n times n plus 1 divided by 6 out. So this becomes S is equal to 1 by 12 n times n plus 1. Now here we'll be left with 2n plus 1, and over here n times n plus 1 is already taken out. We have 2 here, we have taken 6 out, so we have to add plus 3, and this gives us n times n plus 1. This is 2n plus 4, which we can write as 2 times n plus 2. We cancel this and we finally get n times n plus 1 times n plus 2 divided by 6, right? Now let us verify if our answer is correct. You can see that our n in this case is 6, so we have 6 times 7 times 8 divided by 6, so 6 cancels, so 7 times 8 is 56. So if we add 1 plus 3 is 4, 4 plus 6 is 10, 10 plus 10 is 20, 20 plus 15 is 35, and 35 plus 21 is 56. So this formula is correct, right? Now let us consider one more case, and this is a case of rectangular arrangement. Okay, case 3 is rectangular arrangement. We have already seen the square arrangement, the equilateral triangle arrangement, and let us see what is rectangular arrangement. Okay, now in this case I have drawn an example of 5 by 3 rectangle, which is the bottommost layer. Okay, so this is the bottommost. On this layer we can form another rectangular layer of 4 by 2, right? So this is the second most bottom, right? And on top of this we can form the top layer, which is the top layer, right? Suppose we have in the bottommost layer, okay, our bottommost layer is m by n rectangle. Okay, then the second most bottom will be m minus 1 by n minus 1, and we have to do all this way up till n reduces to 1. What will be the value of m here? We have reduced n by n plus 1, right? So we will be having m minus n minus 1, which is actually equal to m minus n plus 1, right? So how many balls we have in the topmost layer? We have m minus n plus 1 times 1, right? So top layer we have m minus n plus 1 times 1, which is m minus n plus 1 balls. Now in the second most layer you will have 2 here, and over here you will have m minus n plus 2, right? So second layer will be m minus n plus 2 times 2, and this will be m minus, I think there's no need to solve this, right? So this is the second layer ball. Third layer will be having m minus n plus 3 times 3, and nth layer, the bottommost layer, will be having m minus n plus n times n, which is actually equal to m times n balls. So you can see that this is 5 times 3 balls. Now if we add all this up, so we have to add all this up. So if you add this, what do we get? So this one, m minus n plus 1 times 1, we can write it as, so I am writing s is equal to the first term, which is m minus n times 1 plus 1 square, right? So I will write here plus 1 square plus this is m minus n times 2, m minus n times 2 plus 2 square, right? Then this is m minus n times 3 plus 3 square, and finally this will be all the way up to n times m minus n, right? Let us be consistent in writing what we are writing. So this will be m minus n times n plus n square. Now you can see that this sum we already know. This is simply sigma n square, right? And if in the top layer we take out m minus n as a common factor, we will get 1 plus 2 plus 3 plus 4, so which is sigma n. So this is simply s is equal to m minus n times sigma n plus sigma of n square, right? And we already know how to calculate both of these sums. So s will be equal to m minus n times n plus 1 by 2 plus n times n plus 1 times 2n plus 1 by 6. And now you can simplify this further. So to simplify, let us take n times n plus 1 divided by 6 out. So s is equal to, I take out n times n plus 1 divided by 6 outside. So you have 3 times m minus n over here, right? Because 6 times 3 will give you 2, and you will be, yeah, and here you will have 2n plus 1, and this gives us n times n plus 1 by 6, 3m minus 3n, so you will get 3m minus 3n plus 2n is minus n plus 1, and that's it.